Hi everyone! In this video we are going to learn how to select an appropriate solvent for an acid-base reaction. So last time we learned how to pick an appropriate base for our reaction. So remember, the conjugate acid of the base should have a higher pKa value than the acid of interest. But how about the solvent? So what do we dissolve our acid and base in? Well, initially you might think, just dissolve it in water. But that doesn't always work. For example, let's say that we have acetone as our acid. So there are some hydrogens here on the end of the molecule that could be donated. And then let's say we have a good base like NH2-. And let's say we dissolve all of that into some water, which is our typical solvent, right? So I'll just write solvent here. Well, remember, water can also act as an acid. So there are actually two separate reactions that could potentially occur here. So NH2 might take a hydrogen from acetone, but it could also take a hydrogen from water. Okay, so what would happen in each case? Well, let's write that out. So if NH2 takes a hydrogen from water, then we would be left with acetone again, because NH2 won't take anything from acetone. NH2 would gain a hydrogen, so we would end up with NH3. And then water would become the hydroxide ion after its loss of a hydrogen. Now, what would happen if we take a hydrogen from acetone? Well, we would end up leaving the shared electrons on carbon on the very end. So we would get an anion. And then we would also end up with NH3 because NH2 took a hydrogen. And then water is left untouched, so that would just remain water. Okay. Now, let's see which one would preferentially occur. So which one is more likely to occur? Well, we need to look up the pKa values for our two acids. So I gave you the Evans pKa table under study guides. So you can look up the pKa values there. I'll just give them to you for now just to make it easier. The pKa value of the hydrogens on acetone is 19.2. And then the pKa of water we saw last time is 15.7. So which is more acidic, acetone or water? Water, because remember, the smaller the pKa value, the stronger the acid. So NH2 is more likely going to take a hydrogen from the solvent than the acid that we're trying to start a reaction with. So the reaction with acetone won't even happen, and then we're just left with more acetone. We're not going to have the resulting product that we want. So this is where you have to be careful when you're picking a solvent. So again, the solvent is the reaction medium. So that's where the reaction takes place. So we don't want the reaction to occur with the solvent. So we want to pick a solvent that is inert. So inert means that it does not react. Now, sometimes it can be helpful to have a solvent that does react, but in this case, we would want the acid of interest and the base to react. We don't want the solvent to react. So really the main message here is don't pick a solvent that is more acidic than the acid of interest. Okay. I apologize if you can hear my washer and dryer going off. Had to do some laundry today. All right, so just some tips. Use a base whose conjugate acid is the same as the solvent. However, make sure your acid and base are soluble in the solvent. So we have a couple of things to think about here. So let's look at another example. Let's say we have acetylene, and we want to react this with NH2, which is a really strong base. Now, this is also a good base to use for this particular reaction because the conjugate acid of NH2 has a much higher pKa than acetylene. So remember, acetylene has a pKa of 24. And when we go through this reaction process, we'll end up forming the anion of acetylene and NH3, ammonia. And the pKa of ammonia, our conjugate acid, is 38. So NH2 is a great base to use for this acid. But again, remember our tip here for the solvent is to use the conjugate acid. Okay, so let's just dissolve everything in ammonia. Well, this will work out great because NH2 will grab onto a hydrogen from acetylene, and then we'll just form more of the solvent, ammonia. But again, you just want to make sure that the acid and the base are both soluble in the solvent. So that's important too. Now, if, for instance, the conjugate acid is not a common solvent, so let's say you get a conjugate acid that precipitates or something like that, then you'll just want to pick something that has a high pKa value. So if the conjugate acid of the base is not a common solvent, then pick a solvent with a high pKa value. So that way the base won't take a proton from the solvent because the solvent has a really high pKa value. So it's not a good acid. All right. So one thing I wanted to show you is on the Canvas website, if you go to modules and then you go to study guides, so under study guides, there's a common bases and solvents handout. So the first page has some common solvents that we use in organic chemistry. And let me just zoom in on this. So there are polar protic solvents, there's polar aprotic solvents, and non-polar solvents. So later on we'll talk more about polar protic versus polar aprotic solvents. But for now, just focus on the pKa values. So the pKa values are all listed underneath. So this can help you pick out an appropriate base and solvent. But additionally, the second page has some common bases that we use in organic chemistry. So on the left-hand side, we have weak bases and their conjugate acids. So you can try to pick a base that has a conjugate acid with an appropriate pKa value. And then on the right-hand side, we have strong bases. And typically we're going to use these strong bases, but we'll see later on that there are uses for weak bases as well. Okay. So the common one that we've been using is NH2. So this will usually come as an ionic compound, so sodium amide. And again, the pKa of the conjugate acid is 38. Now up above that is sodium hydride, and the conjugate acid is hydrogen, which is a gas, right? So that wouldn't be a good solvent because you can't really dissolve things in a gas. So, just keep that in mind as you're going through. Would this make an appropriate solvent? Or, is it impossible to use as a solvent? Oops. So then if you're not sure if something can be a good solvent, you can go up to the first page and look and see if that solvent is listed. Now for the essential oils lab that we did, we used dichloromethane, which has a pKa greater than 40. So this makes a pretty good solvent for acid-base reactions. All right, so I think that's it for this video. We have one more video left for chapter 3, and that will be all about Lewis acids and bases. So I will see you then.